Hello, this is Mr. Gilmore with the 10.10 the Similarity and Area lesson. Now the question is simple. When we scale a figure, what happens to the area of those scaled figures? Let's dive into this. So, if you recall this is from chapter 7, way back when we talked about similarity, that if we're given two figures, a pair of figures that are similar, then they have a scale factor, meaning that if I take so in particular, if I'm given, let's say, f is similar to g, and a is a length of f and b is a length of g, then there exists some scale factor, let's call that scale factor j, that when you multiply a by j, it gives you b, which is then the similarity from our figure f to the figure g. So when we then talk about scaling a figure's area, is area then scaled the same way? So if I were to have a figure, let's call the area of the figure a, and we saw that same scale factor, we saw that scale factor of j. So then what would the post area of our scaled figure be, right? Is it going to be j times a? Well, it's clearly not going to be. Let's actually consider an example of showing that the scaled factor from the area from the pre-image to the pre-scale area to the post-scale area is not going to simply be the scale factor times the area. Let's investigate this with a square. So let's say I give you a square with side length s. We clearly know by our square postulate what the area of that square is. It's just simply s squared. But we are going to scale this by j, which means we take every single one of the square's sides and we scale it by the exact same constant here, j, which means if I've got a square here, the side length is or the side length is just simply going to be j times s, but that's j times s for both dimensions, right? Well, if we square that, right, just like we do with our square area postulate, we square that, we end up with j squared times s squared. So it's not just simply j times our pre-scale area. Our post-scale area is going to be j squared times that. This is going to lead us into our scale area postulate. We can kind of generalize this idea. So let's think about this in terms of two figures. So if two figures have equal areas, and we scale each by the same factor, then the post-scale areas are equal. Think about that, right? If two figures have equal areas and we scale each by the same factor, then their post-scale areas are equal. Now, why does this help us? Because then an immediate consequence of this is because we saw this effect go in for the square, that means the same effect will go in for any figure. So let's say we have a figure f that has an area of a. Let's construct a square s whose area is also the same as has an area of a. How can we do that? Well, simple. Let's just give the side length of square root of a, which then means when we square that, it has the area of a. Now, if we scale both factors by j, then to basically produce similar, right, produce figures similar to the originals, what we find then is with the square, just like we saw, that the area of the square that should be produced is j squared times a. So then by this scale area postulate, the post-scale area for both of these figures, our given figure our given figure f and the constructed square s, they have the same areas. And that means that f also has this j squared times a. So we have kind of a mantra for ourselves. This is what we call the j squared theorem, that when we multiply lengths by j, we multiply areas by j squared. So we multiply lengths by j, we multiply areas by j squared. So let that be your mantra. Essentially, when you dive into this last homework assignment 10.10, looking at similarity area, you'll be investigating this mantra of using our pre-scale area versus our post-scale area. And essentially, if we know two figures are similar, then we use that given scale factor we know that exists between the two. We can also use that in terms of the scale of the area. So just keep that in mind when diving into the 10.10 worksheet. If you do have any questions with this lesson or with the 10.10 worksheet, please don't hesitate to email me. I will get back with you. With that, be good and do good.